Hi, welcome back to Laplace transform chapter. We are now in section 2, where we will discuss the forward transform of Laplace. There are three parts that we are going to discuss. One is the common Laplace transform pair, Laplace transform using online calculator or MATLAB, and finally some examples. These are 13 most common Laplace transform pairs. In this table, there are 3 columns. The first column shows f of t. So we have delta t here, u of t here, and so on. Note that all these function of time is for greater or equals to 0, implying that they are causal signals. In the second column, we have the Laplace transform of the corresponding signal. So the Laplace transform of the delta function is 1. The Laplace transform of the unit step is 1 over s, and this is what we have seen in the last chapter or the last section, where we have Laplace transform of e minus at is 1 over s plus a. Remember also in the last section we mentioned something called the region of convergence. This is the last column of the table. It shows that the Laplace transform f of s is only valid for s greater than minus a, the real part of s. So we look at this table carefully, and we'll use at least most of them or some of them throughout the course. You do not need to memorize them. You can copy them into a Laplace transform table into your cheat sheet for your exams. What happens when you do not have the Laplace transform of a function? Well, you can rely on several solutions. One is the online calculator. You can have Simple Lab, eMath Help, in integral calculator. I'll show you one of them now. Type Google Simple Lab Laplace. The first entry is the Laplace transform calculator from Simple Lab. You'll be now presented with this Laplace transform calculator, and you can enter your function here. To use, you must type the command Laplace followed by the function you are interested in. For example, exponential of minus 2 times t. The answer should be 1 over s plus 2. Press go, and the answer comes out 1 over s plus 2 over here. In fact, it shows you the working as well if needed. You can type very complicated functions. For example, multiply by sine of 3 times t. And you'll see more and more complicated functions of f of s. And I can continue. And so on and so forth. So you can use Simple Lab to verify your answers. I'll now show you another way, which is the Laplace transform using MATLAB. This slide shows you how we use MATLAB. MATLAB has a toolbox called the symbolic toolbox. You must include this when you launch MATLAB. To make your variable symbolic, you use the function called syms, syms, t and s to make them symbolic. You define your function in this way, and then you just type Laplace, your function name, and out comes the answer. Let us now try. We now define symbolic t, s, and a. We say that the function is equals to exponential of minus a times t. And we say Laplace of f. Now comes the answer, 1 over s plus a. So if you want to have more and more complicated functions, for example, times sine times 2 times t, and we have this. So you can try using MATLAB's Laplace or the Simple Lab Laplace to solve functions that you have problems with. Notice that these tools are here available to you only as a help. In the exams, of course, you do not have such tools, and you're expected to do it by hand if necessary.